Assalamualaikum everyone, we are Group 4 and today we would like to present our Artificial Intelligence project titled Smart Waste Classification System using image classification to detect plastic, paper and metal waste. So before we start, let me introduce our group member. First, we have Maizara binti Muhammad Noor. Second, we have Natasha Nabila anak ngaji. Third, we have Nurul Nazira binti Abdul Rahman. And last, it is me, Nurul Tasha binti Razali. Speaking with the introduction. Nowadays, the amount of municipal solid waste is increased rapidly due to industry growth, population growth, urbanization, and changing lifestyle. In Malaysia, this has become a major environmental issue. Although recycling campaign has been introduced, waste sorting is still mainly done manually. This process is often slow, time-consuming, and can lead to incorrect waste classification. As a result, recyclable material may become contaminated, reducing the efficiency of recycling. To address this problem, we developed a smart waste classification system. This system uses Google teachable machine together with a convolutional neural network (CNN) model to automatically recognize and classify waste into three categories: plastic, paper, and metal.
And now I will present the objective of our project. Our first objective is to develop an image classification model that can detect and categorize waste into three categories. First of all is a plastic, metal, and a paper. And then second, we aim to build a simple and a practical prototype that classifies waste in real time, either through a live camera or an uploaded image. And then our third objective is to collect and label a dataset of waste image for each category to ensure the model has enough quality data for training. And for the fourth, we evaluate the model's performance using a standard matrix accuracy, precision, recall, and a F1 score to measure how reliable the system is. And number 5, beyond the technical side, this project aims to support environmental sustainability by encouraging a responsible waste disposal through AI technology. And then last but not least, our objective is to train a convolutional neural network or a CNN on our label dataset and achieve a high classification accuracy suitable for real-world use. In summary, these 6 objectives guided us from the data collection all the way to building a working prototype. Thank you.
Hi everyone, my name is Maizara binti Muhammad Noor with number matrix B032510214. So, in this slide, I will explain methodology. In this slide, I will explain the requirement needed to develop our smart waste classification system. So we have two requirement needed, which is functional and non-functional. The functional requirement describe what the system should do. User can either capture a waste image using a webcam or upload an existing image. The AI model will then classify the waste into one of 3 categories, which is plastic, paper, or metal, and display the prediction result along with its confidence score. And the non-functional requirement is focused on the system quality. The system should provide fast prediction, have a simple and user-friendly interface, achieve a target accuracy of between 70 and 90%, and run smoothly on a web browser using a laptop or desktop computer. If you can see the diagram, this diagram shows the overall framework of our smart waste classification system. First, the user either captures an image using a webcam or upload an image of the waste item through the web application. The image is then sent to the backend AI agent, where our CNN model trained using Google teachable machine processes the image and extracts its features. Based on these features, the model classifies the waste into one of 3 categories, which is plastic, paper, or metal. Finally, the classification result and confidence score are sent back to the web application and displayed to the user instantly. This enables users to identify the correct waste category quickly and support proper recycling practice. That's all from me.
For our dataset, we collect a total of 6,209 images across 3 waste categories: 2,003 images of plastic, 2,215 images of paper and 1,991 images of metal as shown in Table 1. The dataset was kept fairly balanced across all three classes to avoid bias during training. For the training process, we use Google Teachable Machine, which applies transfer learning on a pre-trained MobileNet V2 model. As shown here, we configure the training with 30 epochs, a batch size of 16 and a learning rate of 0.001. These settings were chosen after testing since a higher number of epochs caused the model to overfit, where training accuracy stayed high but validation performance started to drop. Next, in Table 2, we test the trained model using several sample images. For example, a book was correctly predicted as paper with 92% confidence, a plastic bottle was predicted as plastic with 99% confidence, and aluminium can was as metal with 99% confidence, and a key was also correctly predicted as metal with 100% confidence. This shows that the model is able to classify everyday waste items with high accuracy. Finally, Table 3 shows our confusion matrix. Looking at the diagonal value, 234 paper image, 255 plastic image, and 276 metal image were correctly classified. However, we can also see some misclassification. For example, 52 paper image were predicted as plastic and 72 plastic image were predicted as paper. This suggests that the model occasionally struggled to differentiate between paper and plastic, likely due to similarities in color and surface texture. Metal, on the other hand, achieved the highest accuracy since its reflective and texture surface made it easier for the model to distinguish. Now I will demonstrate how our waste classification model works by testing several everyday waste items. First, I will test this plastic bottle. As we can see, the model correctly classifies it as plastic with 99% confidence. Next, I will test an aluminum can. The model identifies it as metal with 99% confidence, which is also correct. For the third sample, I will test a key. The model predicts it as metal with 100% confidence, showing that it can accurately recognize metal objects. Finally, I will test this book. The model classifies it as paper with 92% confidence, which is the correct predictions. Overall, the live demo shows that our model can successfully classify a common waste item into plastic, paper, and metal with high confidence.
So as for the conclusion, this paper presented the Smart Waste Classification System, or SWCS, which is an AI-based solution using a fine-tuned MobileNet V2 CNN to classify a plastic, paper, and a metal waste with a 94.7% accuracy and a 580 millisecond latency per item, costing along about 489 ringgit Malaysia. The prototype is practical for resource-limited settings. By automating waste sorting, SWCS reduces recycling, contamination, and landfill waste. Supporting with the SDG 12 and SDG 13, the future work will expand classification to the glass, organic waste, and e-waste, and add a lot of base bin monitoring for a smarter collection scheduling. That's all from us. Thank you very much.